Hello and welcome to the sixth video in our lecture on the weaknesses of public key cryptography. So in previous videos, we've already talked about the two main weaknesses of public key cryptosystems. The first weakness was that it was very slow compared to the symmetric approach to cryptography. So the way we solved this problem was by using hybrid cryptosystems, whereby we only use public key cryptography at the beginning of the communication just to establish a shared private key for the current session. And then from now on, we just use fast symmetric encryption using that shared key. Now, the second problem with public key cryptography is actually pretty unintuitive, but is actually the flip side of the main benefit of it. Remember, the main benefit of public key cryptography is that you do not have to share private keys because the private key has to be known by only a single entity. On the other hand, what must be shared is the public key. So the main weakness of this approach is the public key distribution problem. Remember, we said that everybody can and should know your public key, in particular if they want to communicate with you in a confidential fashion, then they should know your public key so that it can encrypt their message to you using your public key, and therefore only you can decrypt it with your private key. So we always said, okay, fine, everybody can know the public key, but actually that is a big problem because everybody knows, everybody's public key. Then how do you know that your public key you're using is actually the one that belongs to the person you want to send a message to? And so that is an actual problem that is one of the hardest problems with this approach. And so the solution that's currently being used to solve this problem is called public key certificates. And this is the topic for the rest of this lecture. So to solve the public key distribution problem, we use public key certificates. So before we describe what a public key certificate is, let's take a concrete example. So let's say that you're sitting at home in front of your browser and you want to do a transaction with the Amazon web server. So you're going to use your browser to make an HTTP request, but because you're security conscious, you're using the secure version, or HTTPS, which uses public key cryptography. It's actually a hybrid crypto system, as we're going to see. So Amazon receives your request and it's going to send you its public key, right? So here's the public key of Amazon. And the reason it sends you its public key is that, so for now, say you wanted to send your credit card information to Amazon, you would encrypt it using Amazon's public key in such a way that only Amazon could then decrypt it and get your credit card number. So that's the way that the public key crypto system is used in this case. But of course, the problem is that when you get this public key, how do you know it's actually Amazon's public key? It's just a sequence of bits after all. So in particular, the one thing you want to be aware of is the type of attack we already mentioned called a person in the middle attack. So what if some attacker positions themselves in the middle here and they actually intercept your request, and then they pretend to be Amazon and they are sending you their own public key. So this time is the public key of the attacker, PU prime. But they claim to be Amazon. So when you receive this public key, you think it's Amazon's public key, you use it to encrypt your, say, credit card number, and you send that back. Turns out it's being received by the attacker that will then have your credit card number. So this is clearly a situation that is not good, and that's again a pretty big weakness of the public key crypto system called the public key distribution problem. So the solution then is going to be to use public key certificates. So what is a certificate? Well, a certificate is basically a proof, quote unquote, that the public key you're receiving actually belongs to whoever the sender or whoever claims to own that public key. So a certificate looks like this. The certificate for Amazon will contain the public key of Amazon. It will also contain the identification information for that public key, so Amazon.com and so on and so forth, but some other information we'll talk about later. And then what the importance of the certificate is that the binding between this public key and the owner is that this is signed by a trusted third party, or TTP. So if you trust this third party and they actually signed this certificate, so this is the certificate, so if you trust this third party, they actually went ahead and checked that this public key is actually owned by Amazon.com, and they signed off on it. They actually put their seal of approval. And so what happens now is when you're getting the public key of Amazon, you're actually not getting just the public key. You are getting this certificate. And so the browser is going to get this certificate, is going to look up the trusted third party. If it's a party that it trusts, then it would actually be convinced that this public key is indeed the public key of Amazon and will therefore be able to use it. And from now on, you will be pretty safe in assuming that the person you're sending this encrypted, for example, credit card number is actually Amazon. Now, one thing to realize is that this certificate is not proving that the person who sent you that certificate is Amazon. It has no idea who sent you that certificate. So in particular, it could have been the attacker that sends you that certificate. All the certificate proves is that the public key that it contains is actually owned by Amazon. So of course, this certificate can be available to anyone, including the attacker. So what if the attacker sends you that certificate? Well, you will trust that this is the public key of Amazon, so you will use it to encrypt your social security number, and you're going to send it back. And that's actually okay, because even though this is not Amazon, this is the attacker. Since you use the actual public key of Amazon to encrypt your credit card number, they will not be able to decrypt that message, because Amazon is the only one that actually owns the private key corresponding to this public key. So this is the idea of a public key certificate. Make sure you're comfortable with the big picture here. And we're going to talk a little bit more detail about how these certificates are created and what they contain in a next video. But for now, let's talk about these trusted third parties, as I've been calling them, the TTP. These are actually called, in the context of public key certificates, they're called certificate authorities, or CAs. So this is typically a government agency or financial institution or any kind of institution that the general community trusts to do a good job of verifying the ownership of the public keys. So these certificate authorities, there are many of them throughout the world, but they are basically built into your browser, meaning your browser by default trusts them. So how would you use these authorities to get a certificate, like if you're Amazon? Well, Amazon would go to one of these certificate authorities and it would submit its public key that it just randomly generated and its identification information. And then the certificate authority would check that this is indeed Amazon who is contacting them by either visiting them or calling them or asking for some proof of identity. And if they're satisfied, then they would issue this signed certificate for Amazon. Then Amazon would make this certificate public. In other words, they would send it to you every time you do an HTTPS request. And then anybody who received that certificate and who trusts the certificate authority that signed it would then be comfortable sending their personal information to that server because the certificate guarantees that the public key they're using is indeed owned by Amazon. So the standard that's been used now by pretty much everybody to encode and to format this certificate is the X509 standard, and it's been used widely by pretty much everybody. So it's used by the IPsec protocol within the IP layer in your network stack. It's also been used for SSL, secure socket layer certificates at the transport layer in the TLS protocol. It's used in a secure share or SSH protocol. It's used for encrypted email, secure email, and so on and so forth. So we're not going to go into the details of this standard, this X509 standard. Instead, what we're going to do in the next video is give a little bit more details about the structure of certificates and how they are being signed by certificate authorities.